Hello guys, welcome you all for this end-to-end session of AIML, where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot, and we are learning a lot each and every day. Hope the same thing for you guys. And we are on to the last part of machine learning. Okay, not data science. Okay, we are on to the last part of machine learning where we are just moving on to the gamified version of this reinforcement learning. Okay, so before coming to this session, make sure you guys watch all the previous session videos so that you can have a better understanding of what we are talking. Okay, and one more thing, if you guys doesn't subscribe to our channel, please make sure that you guys subscribe to our channel so that only you will be getting whenever we upload a new video. Right, we are just uploading new videos each and every day, so you're gonna get a notification whenever we're gonna apply, like we're gonna upload a new video to the YouTube. Okay, so that's our thing. So let's, without wasting any time, let us jump into today's session. So today's session is all about Markov decision process. That's an ancient method of doing automation. Okay, let's discuss about it. Markov decision process is a data science in data science. Sorry. Okay. Yeah, Markov decision process are a powerful mathematical framework for modeling sequential decision making problem under uncertainty. They are widely used in various fields, including robotics, finance, healthcare, what are especially relevant in data science due to the rise of machine learning on artificial intelligence. So, as I mentioned, right, this Markov decision process is a very, very ancient process where it is built without knowing they're gonna be AI. Okay, sir is also going to be accepting my statement, right? Because it's a very ancient method, it's a mathematical method where they have built something which is going to predict the things based on the past experience. Guys, just listen to it. Okay, it's a very, very ancient method, and they doesn't know they're going to be a data science field. They're going to be machine learning, AI, ML, DL, and we are having LLM, right? Nothing is known by that. They have just introduced something called as Markov decision process where they're gonna have a state kind of thing, and they're gonna predict the future based on the previous experience. And there is no terms called as A, ML, DL, LLM. Okay. So I can also not able to believe how they have introduced these things. Okay. So yeah, let's discuss about this topic. Okay. Yes, sir. Over to you.
Yes, guys, Markov Decision Process MDPs we say in data science and AIML. So it's very old, and we'll say around early 1950s. It was developed by a Russian mathematician Andrei Markov. So he developed it. So he developed it, and at that point of time, it was not like it is developed for artificial intelligence. Like nobody knew, and operations research it is used, economics, robotics, manufacturing. Okay, so he was a Russian scientist. So you can see Markov. These names are like Russian names. Okay, so he was a Russian scientist. This guy has developed this, and absolutely, it was not developed for AI, but it actually now it is part of AI because it learns from the old experiences, and that's what is. If you see machine learning, we learn from old patterns, old experiences, also the unseen data patterns in the data, and that is what how we make decisions, and the algorithm makes decision. When I'm saying we, that means the algorithm, okay? Because I become character. When I speak, so I become algorithm, like I am the algorithm, whatever I'm speaking, right? So that you consider that way. So I'm making it clear so that you understand, okay? So MDP is a powerful mathematical framework for modeling sequential decision making problems under uncertainty. It is very, very, very important, guys. To understand the uncertainty, to understand future, we have to understand properly the past and present. Okay, so they are widely used in various fields, like including robotics, finance, healthcare, I said manufacturing, research, operations research, like in operations. Okay, input output, what is the input in okay, in operations, manufacturing and all. So where in factories you give X amount of input and then there's Y amount of output. Data science and other healthcare and all, due to the rise of machine learning and artificial intelligence, now it is used very, very regressively, because through this Markov decision processes, you understand uncertainty and make predictions for the future and make decisions according to that. So keep learning, guys, deeply all these algorithms and concepts are so powerful. So if you understand deeply, it will build your foundation, and then your future and career, everything is built on that. So pay attention to each and every detail of these concepts. So absorb the information, digest the information, and apply. Do all the quizzes and the application and the assignments, and with long-term objective function, what you want to become, and become a lifelong learner, irrespective of the degree or the you get salary or not. When you learn deeply, guys, with no expectations, you are actually going to become a world class number 1% person in the world, number one, because you will go very deep, and people don't go deep. They are always broader. They do breadth first search, but depth first search is wherein you will shine and you will become diamond. Okay, so keep learning deeply, absorb the information, digest, and give us feedback, and do reinforcement learning continuously with long-term objective function, with persistence, consistent patience, and perseverance. With these soft skills, learn hard skills and become world class. Keep learning. Let's move to the other session.
Yeah, sure, sir. Let's move on to the next thing what we are having. Okay, yeah, I hope like if you guys are watching our video in the last two sessions itself, we have explained these things. Let's explain again. Okay, defining the MDP process, that is Markov Decision Process framework. A Markov Decision Process is defined by a set of states, actions, rewards, transaction probability. Agent aims to maximize its expected cumulative reward over time by choosing the optimal action in each and every state. The framework consists of current state and the chosen action to determine the next state and the associated reward. Everything is clear, right? Because like I have explained by using the game itself. Okay, we are having a Super Mario game where we are gonna have a Mario character. It's gonna do the actions based on the action. It's gonna get the punishment or reward. Whenever the reward is negative, it's not gonna do that. If it is positive, it's gonna do that. It's gonna increase the positive rewards so that it will reach the goal. That's it. This entire thing is called as a Markov Decision Process framework. Let's discuss one by one. What is state? A state represents a situation or a configuration of a system in a chess game. Sir is explaining with this method, right? Right. Chess game. A state could represent the current arrangement of pieces of boards, piece on the boards. Okay. What is action? Actions are the choice that the agent can take in each state. In the chess example, actions could be moving a specific piece to a particular square. Rewards are the assigned to the state, various values assigned to the state transaction, representing the desirability of reaching a particular state. In a chess, capturing a piece would yield a positive reward. Okay, this is what Sir is explaining. Let's give it to Sir itself. Okay, Sir will explain by using this chess game. Okay, let me explain by using this Super Mario game. What is state? A Mario is standing in the first cell, right? That is called as a state, current state. What is action? The Mario character is gonna move left, right, or up, right? That is what the action. What is reward? Whenever the Mario character is gonna break the brick, right? It's gonna get a coin. That is a positive reward. What is a negative reward? When it breaks a brick and it gets a tortoise, right? It's a negative reward. Okay, yeah, this entire thing, the agent, the Super Mario character gonna do the actions, it get the punishments and rewards, and gonna explore the entire environment, reaches the goal called as framework, the Markov decision framework. Okay, so yeah, sir, over to you.
Yeah, so absolutely rightly defined. So defining the MDP framework. So here we'll understand what a so framework in framework there are three things which we need to consider: states, actions, and rewards, which we already explained. So now let's do reinforcement learning. Let's go deeper and understand it. So MDPs by the set of states, the actions and rewards, the transactions and possibilities. The agent aims to maximize its expected cumulative reward over the time by choosing the optimal action in each state. So what is the objective function, guys? We use AI, ML, or any deep learning model to optimize the objective function, guys. That is the single objective of any model, because we human beings are dumb. Okay, we make machines intelligent and then machines do the work. So machines are also dumb because we have to make them intelligent. and then they become intelligent and we become dumb. So I'll give example of this. uh, Lisa Doll, he is world champion like 17 times. You have chess, it is 9 cross 9, but you have Go game, which is 19 cross 19. So there it is said that 9 cross 9 chess, if you make all the moves, universe has atoms like 10 raised power 76. Okay, atoms are in the universe. So they are saying that you can't make all the moves the universe has the atoms. If you do all the moves, permutation combinations, understand the complexity of time series and time and space, guys. So with 19 cross 19, what would be the situation? I'm saying with 9 cross 9, universe has 10 raised power 76 atoms, and you can't make all the moves. It will take billions of years to do all the moves of the chess. So similarly, see 19 cross 19, and this guy Lisa Doll was 17 times world champion, and then deep learning, reinforcement learning, mixing with other algorithms, this deep mind they have developed, certain scientists, and then it was bought by IBM, or I think Google. Yeah, I think IBM. So they bought it because this algorithm learned over the experiences when he was playing with Lisa Doll, and over the time in I'm say like in 30 days or something, it learned the entire things, and Lisa Doll thought he is losing, the algorithm is losing, he is winning, and then he made a move where he lost the game, and that was a shock to the world. That can an algorithm go so deep and beat the person who is 17 times champion in Go game? So that is what is deep reinforcement learning, guys. You can just imagine that what AI is going to do with the world. Okay, intelligence you can't beat. Okay, state, so represent the situation of configuration system in the EHS, and the state could be representing current arrangement of pieces on the board. I have already explained this, that when you're playing chess, the squares you have, that is the states, like two players sitting together, both the square, like the white ones and the black ones. So both are called states. Action, both they will make action, that would be called actions, and rewards, negative and positive, that would be called rewards. That is simplification of reinforcement learning, that the components of MDPs framework. So this is very simplified, because here we have to make education so simple that anyone, whether somebody has gone to school or not, should understand what we are teaching. Then we'll make happy our great teacher called Flyman, and we have Flyman technique also. So he was the greatest teacher. He got a Nobel Prize. So I admire him, the way he taught physics to people. People used to laugh, like when they come to school, like it's very boring subject, right? But people will laugh in the class, all the classes. People will love, and classes are full when he is teaching. So that kind of excellence he had, he got Nobel Prize, and he was best teacher. We really admire, and our objective is also to make concepts so simple that you learn with ease, you don't have any difficulty. Okay, keep learning deeply. Let's move to the other session.
Yeah, sure, sir. Let's move on. Okay. Yeah. States, actions, and rewards. Okay. Actually, we are discussing this many times. Why? Because these are the fundamental items of reinforcement. Let us discuss again. Okay. States, actions, and rewards. States, actions, and rewards are the core component of MDP. This is what I'm explaining, right? So, a Markov decision process core components are states, actions, and rewards. Agent's goal is to learn a policy that maps the states to action, maximizing its cumulative reward. For example, a robot navigate a room might have a states representing different locations in the room, action representing the movement in different direction, and rewards associated with reaching a goal. Okay, reaching a goal in location. Let's discuss one by one. State space. Set of all possible states in the environment which can be finite or infinite. Consider we are having a Super Mario game, right? There is a character, Super Mario character. On what are the things that it can explore? That is called as a state space. Action space, set of all possible actions that the agent can take in this each state. What a Super Mario character can do? It can jump, it can go left, right. If it is an environment related to ocean, it can swim. If it is related to something like a fire, it can safeguard it, right? So these are the different actions that it can do: left, right, up, and it can swim. That's it. Okay, not related to fire. Okay, so these are the actions that it can do. Reward function, a function that assigns a numerical value to each state, representing the desirability of that state. Okay, what is the reward in Super Mario game? It's a coin. It's a positive reward. Tortoise is the negative reward. Okay, simple. I'm explaining everything by using a simple game. Okay, this is how a data science, guys. Okay, when you are able to understand everything by using a real world example, right? Then it's gonna be very simple for you. Okay, so yeah, this is what all about states, rewards, and actions. These are the core components of MDP. So yeah, sir, over to you.
Yeah, so states, actions, and rewards. I've already explained. Now, again, I'll explain. The state, actions, and rewards are the core components of MDP, Markov Decision Processes. So, they are very crucial, guys. So, the agent goal is to learn a policy that maps states to actions, okay, maximize the cumulative rewards. So that is what actually why we are doing reward positive and negative, because you're engaged and the model, the agent will try to maximize, optimize the objective function. That is the core thing, guys. Okay, here we have to make our sessions so engaging, so gamified, so that you are engaged, you learn properly. So that is the objective function for you guys. We have to do. So same way you have to understand it. Okay, so now for example, a robot navigates a room, might have state representing different locations in the corner, actions representing movement in a different direction, reward associated with reaching goal of location. Like with lesser time, if you cover all the locations, we can give you reward. So this is how agent would be excited. Oh, I want to get reward, I don't want to get punishment, or I don't want to get no reward. So this is how it is gamified. The original concept is gamification, so that the optimization level is achieved in the objective function. State space, it is the state of possible states in the environment. Like in chess, you have all states, that are the possible states. Okay, beyond chess there is no state. That is the environment for your agent to learn or optimize. Okay, can be uh, finite or infinite. Okay, it depends on the environment, guys. Okay, if you're developing a weather algorithm where to predict the best possible prediction, so that can be infinite, right? And there like it can be finite, it can be, or okay, action space is the space, like as I said, the chess both sides, that is the action space. Okay, the possible actions agent can take in each state. For a robot, the room and the lobby, wherever it has to clean, that is the action space where the action will take place. Okay, and then the reward function is the function that assigns the numerical value to each stage transaction, representing the desirability of the transaction. So how you can reward a robot, how you can make happy a robot, because it would be, I think, when you give him certain rewards, like it can be only through machine language, guys. So suppose one is that okay, he got a reward, zero is like it is not getting the reward. So that this is how you can make machine happy, because he got a reward or he did not get a reward. Or he will make a sad face if he is not getting a reward, but he makes a happy face, and through numbers only, machine language, till we go for quantum computing, where we have superposition and we have other senses, so that we make machine happy or unhappy, or the agent. Okay, let's move to the other section. Thanks.
Yeah, sure, sir. Let's move on. Okay, yeah, we are having next thing, that is transactional probabilities. Okay, I hope like we have discussed this, but like not briefly. Let's discuss this briefly. Okay, transition probabilities determines the likelihood of a transition from one state to another state, specifies a by given by a specific action. These probabilities are essential for predicting the future states and optimizing the decision. They often depends on the current state and the choice of actions. Okay, what is the transition probability? Simple. From one state, I'm gonna move for the another state. Like in a Super Mario game, the character gonna move from one state to another state based on action, whether it is a left, right, or up. Based on it, it's gonna get the rewards and punishment. That is completely different. Moving is an action which is done from one state to another. That is called as a transition probability. Okay. State one, agent is in state one. Action A, agent takes an action. Then state 2, agent transition to the state 2 with a certain probability. Consider, we are having a Super Mario character in state A. It need to move to the state B. There is a gap in between. So we need to jump. That is called as an action. So Super Mario character from state A moves to the state B based on action of jump. That's it. That is what this transition probability, that jump should be some probability. That is agent transaction to the state 2 with certain probability. That's it. Okay. I have simplified the things. Okay. So yeah, sir, over to you.
Yeah. So probabilities. So we have already known MDPs are known for predicting uncertainty, guys. So determining the likelihood of transactions from state to another state giving specific actions, these probabilities are essential for predicting future states. So once you learn from the past experiences, guys, and then you will be able to predict the future states, because it's not based on human beings do it based on emotions, but here it is completely based on data, guys, which is proven data, right data. It's not based on notions and pre-notions and visualizations. Here it is based on facts. That is why becomes more powerful in terms of, suppose you want to predict a mutual fund who has performed for last 10 years, and then you are applying reinforcement learning or MDPs. So then what will happen, you will see what is the average, so you are going to invest. So 15% average is a good return. So suppose there is a 10% inflation and still you are in profit of 5% learning, like you have investment ROI on the investment. So optimizing decision, again, whatever decision, wherever you can use this, and this is going to, it often depends on current state and chosen action. State 1 is agent is in the state 1. Action 2, action A is the agent takes action A. Okay. State 2, the agent transactions to state 2 with certain probability, because then when it goes to state 2 it has learned something. Okay. Then it goes state 3. That's why when you see, if you see the paper on deep learning and go study that, so you can see when the deep learning, that deep mind learned, uh, earlier it was at a stage for few days it was very slow in learning, but when it reached optimality, so then it jumped and it defeated Lisa Doll, and that is the power. Like it goes exponential, right? It goes very high. So that is the, like if you have seen bamboo trees, they go 3 4 years down, and then when they shoot up they are like the highest trees, right? So you will see how they are growing, right? But they have gone very deep, so they have learned that how they can go up. So keep learning deeply with reinforcement learning, guys. That's why reinforcement learning, I keep using it for learning. So keep learning deeply with long-term objective function, with patience, persistence, consistency, and perseverance, and long-term objective function, and become a lifelong learner. And write in the comments and give us feedback, guys. We love feedback to improve our sessions each time, because we are for you, we are serving humanity, and we are for you guys. So write in the comment section. So we are always there to serve you. We are planning another 1 year program for deep mathematics for AIML, and then how we can design algorithms in the future. So those would be very deep things, but first learn this properly so that we can go deep and deeper, deeper, deepest. Okay, keep learning deeply. Let's move to the other section.
Yeah, sure, sir. I think we can pass here. Okay, because like we have introduced you to the Markov decision process, is an ancient probabilistic method which is helps us to predict the future based on the past experience. Okay, we have introduced you that. and then the key components, or what is transaction, like different key terms that we have discussed today. Okay, guys. So this is all about today's session. I hope like you guys have enjoyed. If you guys have any doubts, just pick in the comment section. We'll take up and we'll solve your doubts. So until next session, guys. Bye. Take care. Keep learning. Bye, guys. Take care. And we'll all meet in the next session. Bye, guys.